This is a review of the acceleration word problems. So we're going to start with this problem of 15 meters per second to 22 meters per second. In 4 seconds, what is the eagle's average acceleration? So let's write down the acceleration equation, okay? And that's going to be A is equal to the change of velocity over the change in time, which is also equal to the final velocity minus initial velocity over final time minus initial time. Right? And so they give us a couple pieces of information that we're going to use. Let's see. So they give us our initial and our final. So our initial is 15 meters per second. Our final is 22 meters per second. And our time is 4. So they're asking for the average acceleration. So this is our unknown. We're going to go ahead and write our equation. A is equal to, since they give us the VF and VI and the change in time, we're just going to take this part and this part. So we'll have the final velocity minus initial velocity over the change in time. We'll replace the variables with the numbers that is given to us. So we have 22 meters per second minus 15 meters per second over 4 seconds. Okay, and what we're going to get is that it is 22 minus 15 is 7 meters per second over 4 seconds, which is equal to, positive 1.75 meters per second per second. And what that means is, for every 1 second, 1 second, the eagle speeds up. I don't say accelerate because in our class it could mean speed up or slow down. Speeds up, how do I cancel this? Speeds up by 1.75 meters per second. And that's how we do number 1, right? And so now for number 2, we have a pilot decreases the landing speed from 70 meters per second to 7 meters per second in 30 seconds. So we know that the final velocity is 7 meters per second. The initial is 70 meters per second. And the change in time is 30 seconds. And we're looking for the acceleration once again. Okay. And since we have this, we will use the same thing that we did for our previous equation, which is, our initial, final minus initial. So we have 7 meters per second minus 70 meters per second over 30 seconds. So here we get negative 63 meters per second over 30 seconds, which is equal to negative 2.1 meters per second per second. And what that means is for every 1 second, the plane the plane slows down. That's what this means, slows down by 2.1 meters per second. And so I already addressed this second over here, okay? And so that's why we write our sentence like this. All right, and for our last problem, we have the roller coaster picks up speed as it rolls down the slope. As it starts down the slope, its speed is 4 meters per second. It accelerates at a rate of, they give us the acceleration, 6 meters per second per second. And it's asking for the velocity after. So velocity after means final velocity. They give us the change in time, which is 3 seconds, and the initial velocity at 4 meters per second. Right? And so what we're missing is the initial velocity. So this time we'll use a is equal to final velocity minus initial over the change in time. And since we're trying to get, the final velocity, since what we are trying to find is this guy right here, we have to get rid of everything else. And the way we do that is through algebra. We're going to multiply by time first, and that cancels out. So we have a times time is equal to VF minus VI. And we'll just add VI. We're just going to go ahead and add VI. And what we get is, so just go down over here, is A times delta T plus VI is equal to VF. And now what we're going to do is substitute the numbers here, here, and here to solve for this. Remember, this is our unknown. All right, and so we have our acceleration is 6 meters per second times 3 seconds plus 4 meters per second, which is equal to the final velocity. We have 6 times 3 is 18, and one of these cancels out, so it's just 18 meters per second plus 4 meters per second. And we have 18 plus 4 is going to be 22 meters per second. And our written description here is we're explaining acceleration. We're going to explain what this number means. And for us, it means for every 1 second, the car speeds up 6 meters per second. That's it.